Now we're looking at limiting reagent. Now limiting reagent is the same thing as limiting reactant. So when you hear reagent, it's the same as reactant. I don't know why they just don't call it limiting reactant, but they call it reagent. So if you hear reagent, it just means reactant. Now that just means when you have your reactant, A plus B goes to AB, one of these will limit how much product is made. Because usually you don't have perfect amount of A mixed with perfect amount of B to have AB. You're going to have some left over. Now, example of this limiting reagent, limiting reactant you have in your daily life. If you're given 12 loaves of bread, a gallon of ketchup, and 3 pieces of bologna, how many bologna sandwiches can you make? Well, one of these ingredients, either the bread, the ketchup, or the bologna, is going to limit you in how many sandwiches you can make. The limiting reagent is the reactant you run out of first. The excess one is the one you have left over. So we can pretty much probably figure out that the limiting reagent here is going to be your bologna because we only have 3 slices of it. Excess will be the 12 loaves of bread and the gallon of ketchup. And it's the limiting reagent that will determine how much of product you can make. So if we're using this example of the bologna sandwich, if we say that to make one bologna sandwich, we need 2 slices of bread plus 1 tablespoon of ketchup plus 4 slices of bologna goes to 1 sandwich, which is a BRKBO, and we'll just balance it like this. We can see what's the limiting reagent. The bologna will be, because we were only given 3 pieces. So obviously the bologna is going to be the limiting reagent. These will be in excess. Now let's say all our sandwich requires is 1 piece. So a new equation, we have for 1 bologna sandwich, we have 2 pieces of bread plus 1 tablespoon of ketchup plus 1 piece of bologna will make our sandwich. Even though we have 3 pieces here, it's still going to be the limiting reagent. We'll be able to make 3 sandwiches, but it's still going to limit us with as much how many sandwiches we can make. Now, if we had 5 million pieces of bologna, well, then probably the bread or the ketchup would be the limiting reagent. So let's try it with actual chemicals. Now, how do you find out the limiting reagent? Well, really, it's the reactant that makes the least number of moles or grams of product is the limiting reagent. And you're basically, to find this out, you're going to do 2 mole-to-mole or gram-to-gram stoichiometry problems. So just like we did before, but we're going to do 2 within the same problem to figure out which will make the least amount of product. And we can figure that product in either moles or grams. Now what we have to know about this is there's really many different ways that we can solve limiting reagent problems, especially if you're just given moles. But I'm going to show you the way that's just more consistent with going from grams to the grams of product. And I just think it's, just a little more conceptually easier because it's just more consistent with what we've been doing. Now, when you're looking at limiting reagent, we can even just look, especially if we're just given moles, we can just look at the equation and say, well, if there's 2.7 moles of ethene, which is C2H4, and there was 1 in the problem, that means there's 2.7 moles of ethene given. And then there's a 6.3 ratio to 3, which equals 2.1 moles of oxygen. And this is the smaller amount, so that will be the limiting reagent. I mean, you can just look at the equation and do that if you wish, but I'm just going to go ahead and show you The way that we're going to do not only with the moles but also going from grams to grams, because this is going to be consistent with the way we look at how much product is made anyway, because once you find limiting reactant, you're going to have to find out the product in most of the problems, and then how much excess reagent is formed. So you're going to have to do this technique anyway. First thing you're going to do, we're just doing mole to mole ratios. We're going to go from the mole of C2H4 to the mole of product, and they don't tell you which product, but let's just pick water. So how many moles of C2H2 will produce how many moles of water? Likewise, how many moles of oxygen will produce how many moles of water? And we were given 2.7 and we were given 6.3. And the one that is the least amount produced, the least, will be the limiting reagent. Let's just go for this. 2.7 mole of C2H4. We're just going to do a mole to mole ratio. We have, from the equation, we have 1 mole of C2H4 and 2 mole of H2O. That equals 5.4 mole of H2O, and we have 6.3 mole of O2, and then from the equation we have 2 mole of H2O per 3 mole of O2, and that equals 4.2 mole of H2O. So we can see that this is the smallest amount. So the oxygen, that's like the bologna, that made the least amount of sandwiches. This is the limiting reagent. It made only 4.2 moles of water. The ethane produced 5.4 moles of water. So this is a limiting reagent because it produced the least amount of water. Now let's try this one. This one has grams given and grams, how much grams is produced. Now these are just like those stoichiometry problems. You're just going to be doing 2 now. You're going to be doing 1 for magnesium to magnesium chloride, and then 1 for hydrochloric acid to magnesium chloride. So that's the first one. The first one we're going to do is for magnesium. We're going to do grams of magnesium to moles of magnesium, just like we've been doing. And then from moles of magnesium, mole ratio, to mole of magnesium chloride, then to grams of magnesium chloride, just like what we did. The second problem we're going to do is grams of hydrochloric acid to moles of hydrochloric acid to mole of magnesium chloride, and this is now exactly the same to grams of magnesium chloride. Alright, so let's just start with the grams. Let's do the first problem there. Problem number 1, we start with 10 grams of magnesium, and we want to go to moles of magnesium. So in 1 mole of magnesium, we have 24, remember we get the molar mass here from the periodic table, 0.31 grams magnesium. Alright, that's the first part. The second one, mole ratio from the equation. We have 1 mole of magnesium to 1 mole of magnesium chloride. And now we have 1 mole of magnesium chloride with the molar mass of magnesium chloride, that's 95.21 grams of magnesium chloride. And we'll see how much 10 grams of magnesium can make, how much magnesium chloride that can make. That's 39.16 grams of magnesium chloride. So 10 grams of magnesium can make 39.16 grams of magnesium chloride. Now we'll save that and do the next problem. Part 2, 12.0 grams of hydrochloric acid. And we're going to multiply that by 1 mole of HCl. And the molar mass is 36.46 grams HCl. Mole ratio, we have 2 mole of HCl per 1 mole of MgCl2. Okay, then mole ratio, then we do 1 mole of MgCl2 per, same thing, 95.21 grams MgCl2. And what do we get? Okay, and I'm sorry, my computer keeps crashing and just erasing everything, so all this data went away. But we multiply it out and we get 15.67 grams of magnesium chloride produced from 12 grams of hydrochloric acid, whereas the 10 grams of magnesium produced 39.16 grams. So this is the least amount, and hydrochloric acid is going to be the limiting reagent. So that's the limiting reagent because it produced the least amount of magnesium chloride. Okay, let's try this other one. If we have 10 grams of copper reacting with 3.83 grams of sulfur, how many grams of product will be formed? Here's our equation. So let's start with 10.6 grams of copper. So again, we're just going to do stoichiometry problems for copper, grams of copper to grams of copper sulfide, then grams of sulfur to grams of copper sulfide. Whichever one produces the least amount of copper sulfide will be the limiting reagent. And so these are just stoichiometry problems. Let's do copper first. This is the first thing we're going to get. That's the molar mass. Then we're going to do the mole ratio from the equation. Mole ratio from the equation, then multiplied by the molar mass of copper sulfide, and that will produce 1.3 or 13.3 grams of copper sulfide. Now let's try the sulfur. 3.83 grams of sulfur. We multiply it in 1 mole of sulfur, that's 32.06 grams. We multiply it by the mole ratio from the equation. 1 mole of sulfur is to 1 mole of copper sulfide, and multiplied by the molar mass of copper sulfide, and we get 19.09 grams of copper sulfide. So we can see which one produced the least amount. This copper, 10.6 grams of copper, produced the least amount of copper sulfide. So that is the limiting reagent. It's the least amount. Very exciting.